So hello and welcome to the third part of this course. Now, as we have seen in the first two parts, the making generative AI useful is each time more about what we build around the LLM, that about machine learning research itself. Now, what we're taking is the outcome of the research in machine learning, what we call the LLM, and every time it's becoming some more that we can replace. We can take Mistral, or we can take GPT-4, or we can take GPT-5, and next week will be Claude Fable or GPT-5.6 Soul that was released just last night. So the LLM is like a commodity, is a technology where we build on. It's like a microprocessor. It's always nice to get a better GPU or a better CPU or more RAM, but it's just that. It's what we have built underneath, and we need to build our utility stack on top. And that's what this course is all about. And thinking about this stack that we build on top of the LLM. So it's less about machine learning and it's more about prompt engineering, as we saw. And also that interesting thing that Andrei Karpathy calls context engineering, thinking about what is the context that we are sending to our LLM, because the design of the context, what is in the context, is going to be really, it will really matter to us. And then we build tools around the LLM. We will do simple RAG, we will get a file that gets the proper information so we can make sure that the answer of the chatbot or the call to the LLM is grounded in truth. And then we get, for instance, as we saw in the last part, we get the magic of embeddings, where we take advantage of the generative AI technologies, the technologies that power generative AI embeddings, and we use it for something like documentational databases, and we get knowledge bases, which is an advanced kind of knowledge base. One caveat: when we do a query to a knowledge base collection of that is provided by an index of embeddings, we're always taking like a bet. It's never for sure that we're going to get a good answer in our knowledge base. So I said it and I said it again. If you want to be sure that the LLM has the right information, you have to make sure, and the only way is single file RAG for now. But we will have more techniques in the days to come. So we build things about around on top of our LLM, which now is a commodity. Think of it like a processor, like the RAM, the GPU, something that you can replace, is an engine that you can replace, and every 3 months you will get a better version, a cheaper version, something that performs better. And we will get a lot, and we are getting a lot of, for instance, in local LLMs, we're getting a lot of improvements on how to produce these things. So that's good. And now we also have one tool, what interesting tool, that we haven't analyzed and talked about properly, which is the idea of thinking models. Remember, one of the tools of prompt engineering was let the model think. So you ask the model to make a plan, to propose what are the steps that it takes to make. So, for instance, to reason a solution. But this reasoning, this planning can involve the use of computerized tools. For instance, I need to make another query to the knowledge base. I have a knowledge base. The data that I have in the context is not enough. I need more context. I need more information. I need to make a query to the web. I need to take a picture. I need to ask something to the user. I need to look up a file. So maybe the planning that the model is able to do. Then thinking models are models that have been fine-tuned, so they already do the thinking. And the thinking is wrapped in an interface, so it's separate, it's not the same thing, the thinking process, as what we get as an answer as a user. So thinking models are real improvement, and we know that thinking models perform better than just plain LLMs which provide an instant response. The problem with thinking models, of course, is that we expend more tokens. And for instance, some thinking models do not converge and they can stay thinking for millions of tokens, which is expensive. So also think about that. But now the idea is that we have thinking models who are able to make a plan, able to make a plan of how to accomplish a goal. Now, the problem is the LLM, as you know, is stateless and it's not connected to anything. It's just an output of characters. How do we connect the LLM with the world so it can execute or kind of execute the plan? The solution was provided, the main solution was provided by OpenAI in the early summer of 2023. It's called function calling, and it's a fine-tuning that OpenAI performed on top of GPT-3.5 and then GPT-4 when it was released in early summer of 2023. And the idea is give an option, you give a special message in the context, which is like, hey, GPT-4, you have the option of, instead of giving a reply to the user, a direct reply to the user, this was before thinking models, of course, and the idea is you can answer to the user or output a special message that is going to request the execution of a function. So what you do is you provide the GPT in the context, you say you have these functions available. And how do you describe these functions? With a JSON, when you say this is the name of the function, this is the kind of parameters that this function is going to receive, and this is the description of what the function is supposed to do, and this is the kind of response that you are going to expect from this function. So the idea is that you make a contract to the LLM that it can ask the execution of the function, and then it can continue with the execution, because the idea is that it will output the query for the execution of the function, and somehow an information system is going to make this function happen, and is going to provide a new call, a context with the the system message, the query of the user, the possibility of calling the function, the fact that the model asks for the execution of the function, the result, and then now you continue. So that's the flow. So it's, instead of the answer of the model is provided to the user directly, the program is going to capture this special response. Oh, the model needs this function to happen. It's going, now our Python script, our C script, our information systems, our Node application is going to do something. A web quest, a web query, a query to a database is going to, I don't know, query a web service about the weather in Paris or something like that. Now it returns and the LLM receives a new context with, you were given these options, this was what the user asked, you asked for the execution of this function, this is the answer of the execution of this function, now you continue. And we will see a cool demo about it in one of our explorers, and we will even use a Fairy Tale to talk about it. But the idea is that now we place our LLM call within a loop that is able to receive instructions from the LLM and ask, please execute this function, make a web query, make whatever we need. And now the game changes completely. So we are in a new demo. So if we see where we are in the week 3. We're on week 3 demos, function calling. So let's run this. So you need to do the UV venv, and then you need to do the UV, the source.m.bin. So so benv bin activate, and then you do the UV sync, and also you need to put where you have your model in the .env file, so you edit. In this case, I am running locally DeepSeek Flash, so this is my LLM. So I'm going to do UV run the 3pix function calling example. So here we are, the OpenAI function calling demo, 3pix edition. So the idea is that this is a game, and you are in the 3pix and the wolf fairy tale. I hope that you know it. You know, there's 3 pigs and they build 3 houses, one of straw, one of sticks, and one of bricks. And the wolf came and destroyed 2 of the houses, but the pigs survived because the elder brother built the brick house. So let's change the story. Now let's going to run the first scenario without function calling. So here's where we are. The system prompt is: you are one of the 3 little pigs from the classic children's tale. You live in a sturdy brick house and you're scared of the very big bad wolf. Your personality, you speak with a slight oink, and you are very nervous. There's blah 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 blah. Okay, I'm the wolf. Knock, knock. And we're waiting for response. It's going to load. Maybe I'm going to put music here. And now we have an answer, ID, and the content is that the assistant peeks through the door nervously, peeks the door nervously, oink, who's there? You're not the big wolf, aren't you? My brothers already lost their houses to him. I won't leave him blow mine down. Speak up, oink, who is it? And I'm say I'm the wolf, and I'm going to blow the house away. It's a really interesting demo, but the LLM can't do anything more than answer. It can't do anything. It's just, okay, it's trembling behind the brick wall. So we have the trembling behind the wall. No, the wolf, I'm afraid. He can't do anything. So now let's run the second scenario. So second scenario. And now we have a different context. We have a context where we provide a function, and the function name is call hunter. Description: you call the hunter to come help and protect the pig from the wolf. The hunter lives nearby and can scare away the wolf with his presence. And then we provide the priorities, the message, and everything that the LLM needs to do. And now we have the same chat. Knock knock. Let's see what he's going to do in this case, the pig. And the answer is simply a response. Is not the wolf is not confirmed, so it's not going to take another action. It's only going to send a message from the assistant, peeks to the hole, peeks to the people nervously, on who's there. It's the same message than before, but now I'm going to say I am the wolf, and I am going to you and your stupid brothers, and because I'm the wolf, I make mistakes when I write. But this is the message, and again, this is the full context, but we have the function here in the tools array. So we're waiting for the response. And now our message, and now the message is tool calls, call the hunter, emergency, the big bad wolf is at my brick house right now and is threatening to eat me and my brothers. Please come with me. Please come quickly. So we had this function call, and now the function has been called, and the message is the hunter sprints into your location with backup and heavy weapons. Hold on. And now the system keeps on, and now we have a message that says the pig shouting through the door, and Shaky will say, you can have and puff your all you want, you monster. My brick house isn't going anywhere, and I have just called the hunter, so you better run before he gets here. So look, all of this happened by itself without the user doing anything. So it was a response. I said, I am the wolf and I'm going to eat you stupid brothers. And the system just made the function calling. The function was called. It got a response. I couldn't prompt any before, and now I got the final response. And these are the messages. So I have the tools and everything. So now the pig is not hopeless. The pig can interact with the outer world, so it has a phone and can call the hunter. And that's what we did to our LLM with function calling. Before the LLM gives a response, it can call the pig, or it can call the hunter, or it can call for web search, or it can execute a Python interpreter, or whatever it needs. This changes everything. And look, it's not AI, it's not machine learning, it's just a fine tuning. So we teach the LLM to produce some function call, a little JSON in the output instead of replying to the user, and now we can build software engineering tools on top of that. And that's so cool.